Hey guys, this is Carrie. We got some background noise today, but it is what it is, so we're just going to do these problems. So determine the sum of the first 30 terms, the sequence whose first 5 terms are 11, 14, 17, 20, and 23. So you want the sum of the first, oops, the pencil is not connected, give me 1 second. Hopefully this connects it. We want the sum of the first 30 terms, so here we go. S sub 30 is equal to 11 plus 14 plus 17 plus... Now, they only gave us 5 terms here, so we have a 30th term at the end that still needs to be determined. So, let's do it. Changing colors. A sub 30 is equal to, we start with the first term, 11. Each time we advance to the next term, we add 3. So to get from the first term to the 30th term, we have to add 3 29 times. A sub 30 is equal to 11 plus 3 times 29 is 87. And we get A 30 is equal to 98. Next up, now comes the time where we have to find the series. So the series is going to be the version where we add all the terms together. So we'll use because this is an arithmetic series where the difference is plus 3, we'll use the forward-backward method. Okay, so we've got the series written forward. We'll write the series backwards. 98 plus, well, I know because it's going up by 3 each time, that this one will be 95 plus 92 plus... And in class today we didn't use these terms, but they're easy enough for me to generate, so why not? Alright, so let's add these two sequences together, or series together. We get 2 s sub 30 is equal to 109 plus 109 plus 109 plus a whole bunch of 109s. In fact, because we were adding 30 terms before, there's 30 of these. So what we get is we get 2 s sub 30 is equal to 109 times 30, divided by 2 on both sides. S sub 30 is equal to 30 times 109 divided by 2. And I don't have a calculator on me, so I'm going to leave my final answer like that, but you should find the final answer for yourself. Okay, there's a typo on problem 2. Determine the first 666 terms of the sequence. Because this is an arithmetic sequence, the first term should have been 4. Once you make this correction, it solves very similarly to the first one, so I'm going to leave this one for you guys to figure out. Wait, should it have been 4? No, it should not have been 4. It should have been difference of 4, so it should actually be 3, excuse me. While training for a marathon, Jessica runs 30 miles in her first week. If the training program lasts 25 weeks, and each week she increases the number of miles that she runs by 4, then we've got 2 problems to answer. So how many miles will she run in the final week of her training program? So in week 25, we can jump straight to the number of miles that she runs in this week by saying that Jessica started with 30 miles. Each week she runs 4 more miles. So to get from week 1 to week 25, that's 24 increments. And so A sub 25 is equal to 30 plus 96. A sub 25 is equal to 126 miles. So she's really come along. In 25 weeks, she's gone from running 30 miles to 126 miles. So next up, what we need to do is we need to figure out, for part B, how many miles Jessica will have run in total. So that's actually S sub 25, the total number of miles she runs over all 25 weeks. So we'll have 30 the first week, whoa. We'll have 30 the first week, 34 the next week, all the way up to 126 miles in her final week. We'll use, because this is an arithmetic sequence, increasing by 4 each time, we'll use the forward-backward method. So we write it backwards, 126 plus ... Because this is an arithmetic sequence, when we add these we get 2s sub 25 is equal to 156, and each one of these is going to add to 156 if we add it column by column. So in fact, we've got a whole bunch of 156s. To be exact, we have 25 terms here. Each one of those gives a 156, so we have 25 terms here. So you get 2s sub 25 is equal to 25 times 156 divided by 2. S sub 25 is equal to 25 times 156 divided by 2. Again, I don't have my calculator. You'll have to find a final answer. I didn't get it, but you will. All right, for problem number 4, the following problem could be solved using a calculator to add the 12 terms below. But try to use the algorithm that we discovered in class to find the sum. So we need to sum the first 12 terms of this sequence. So I'm going to say s sub 12 is equal to 5 plus 10 plus 20 plus 40 plus 80 plus 2560 plus 5120 plus 1040. So this one's a little bit different from some of the sequences we've seen before. This one, the pattern is times 2 each time, which makes this a geometric series. So because this is a geometric series, what we have to use is I called it the shift method in class. And so the idea with the shift method is we need a way that will shift the 5 into 10, the 10 into 20, the 20 into 40, to shift this whole sequence one term ahead. And it looks like to turn one term to the next term, the pattern here is times 2. So what we're going to do is we're going to do 2 times every term. So that will give us 2s12 equals 2 times 5 is 10, 2 times 10 is 20, 2 times 20 is 40, 2 times 40 is 80. So each term, when you multiply it by 2, generates the next term. So we're going to have a whole bunch of these. The one before 2560 will generate a 2560. 2560 will generate a 5120. 5120 will generate a, oops, I missed a number there, 10240. And 10240 will generate 20,480. So the second group represents 2 times the initial sequence. And the reason why we did 2 times it is 2 will shift each term to the next term because 2 is the common ratio. So this number will be different in different problems. Now here, because we have so many common terms, the 10 and the 10, we'll subtract them instead of adding them. 10 minus 10, 20 minus 20, 40 minus 40, 80 minus 80. All the common terms cancel out, leaving us with s sub 12 minus 2s sub 12. Well, we had one of them. We subtracted 2. That leaves us as negative 1 s sub 12 equals 5 minus 20,480. Lastly, we divide by negative 1 on both sides. And remember, if you're using your calculator, put parentheses here, so you get s sub 12 is equal to 20,475. Next up, we've got problem number 5. Consider the sequence below. So again, this is a geometric sequence. The pattern is times 4 for each of these. So we start off by finding some of the terms. A sub 8 is going to be equal to, let's use the explicit formula. Start at 1, multiply by 4, to get to the 8th term 7 times. A sub 9 is equal to, start at 1, multiply by 4, to get to the 9th term 8 times. So I wish I had my calculator on me. Let's see, I'm going to quickly run to my phone and use that. Alright, sorry for the delay here. 4 to the 7th power is not something that I can do in my head, but using the calculator, we've got 16,384. And then for 4 to the 8th power, we've got 65,536. So now for part B, what we're going to do is we're going to find s sub 9. What we get when we sum the first 9 terms of the sequence. Not this one. Oh, another typo. We're actually summing this sequence. So 1 plus 4 plus 16 plus 64 plus all the way up to these last 2 terms that we just determined. So again, because this is a geometric sequence, we're going to use the shift method, where we try to shift the sequence ahead of a term. So when we shift it, we'll have to turn 1 into 4, 4 into 16, we have to multiply the whole thing by 4. So that will give us 4 s sub 9 equals 4 times 1 is 4. Oops, this is too pale. 4 times 1 is 4, 4 times 4 is 16, 4 times 16 is 64, 4 times 64 is 256, ... 4 times this one will give us this one, 4 times this one, back to the calculator on the phone. Man. I wish there were smaller numbers here. 26,02144. So, because we have so many common terms, 4 and 4 here, to cancel these out, we have to subtract this whole thing from this whole thing. That leaves us with negative 3, s sub 9 is equal to, these all cancel out. Even though we didn't write 256, we know 256 will be there. Even though we didn't write 16384, 16384 will be there. These cancel out too, leaving us with 1 minus 262144. Divide by negative 3 on both sides. That gives us s sub 9 is equal to, let's do the math on our phone here. Gotta use parentheses here if we're gonna use our calculator. So 1 minus 262144, close parentheses, divided by negative 3 gives us 87,381. Great. So I hope this helped, guys. Sorry for the typos, but it is what it is. I think the homework set's still a good homework set, and I think it does a great job of reviewing what we learned in class. See you guys tomorrow. Hope the background noise wasn't too